Hi guys, uh, I've shared my screen with you, so can you please confirm if you're able to see the screen? We are about to start with the webinar, all right? Can you please confirm if you're able to see the screen, all of you all? Perfect. All right. So before I start off, uh, I have an agenda for the session. So the agenda for the session would be to discuss some advanced concepts of statistics. Basically, I'm going to pertain myself to explanation of the maximization and minimization concept. I'm going to also discuss about weighted averages, the concept of mixtures, how to use them, where to use them, and I'm also going to discuss about standard deviation and, if time permits, some normal distribution. Okay, so if you can also type in the chat window what are the problem areas that you face in statistics, especially descriptive statistics, I can put in a explanation here and there on the problem areas that you have. So quickly, if you can type in what else you want me to discuss during the session, I'll try to make some time for that also in the 1.5 hours we have. Okay, so quickly type in the chat window what is the problem with descriptive stats that you face. Guys, can you hear me? So can you please type in the chat window what would you want to be discussed beyond what I'm already discussing here. So the agenda for the session, like I said, Moksha, I can't, I won't be able to do modulus questions here because it's the agenda is for a statistics webinar, right? So anything regarding the statistics, if you have any problem areas in stats, I think that can be addressed in this session. Okay. Okay, set theory is like a vague explanation. Probability would be the second part of stats. I'm dealing with descriptive stats today, Vimal. All right. Okay, so just a couple of things. Okay, just a couple of things. I'm also going to open up a Word file so that I can explain a couple of concepts before we move on. Okay. Okay, fine. So range and SD. So why do business schools gives you the 80% median, mean, etc.? Okay, that would be more of a normal distribution question because your entire GMAT score and the entire uh, you know basically when you have a population, when you have a sample size, you're always going to have data which is going to be represented in a bell curve, right? So the bell curve is made use of to explain about the percentiles and the mean and the median and so on. All right. All right, guys. So I'm going to start off. I'm going to start off with discussing the concept of allegations and mixtures. Okay. So many people have a problem with this for some reason. Basically, what this is what the GMAT refers to as a weighted average concept. Okay, it refers to this as a weighted average concept. Now, what the GMAT explains in terms of weighted average is this. Say if I have a class and the average score of that class is 80, and there are a total of 20 students in that class. Say we have another class, the average score is 70, and here we have 30 students in the class. Now, if I combine these two classes, if I need to find the combined class average, then we just can't add the two averages and divide by 2 because here clearly the number of students are different. So to find the combined average of the two classes, what we do is we find the sum of the marks of the first class, we add the sum of the marks of the second class, and we divide it by the total number of students, right? So 18 to 20 is 1600 plus 2100 is 3700 divided by 50, and dividing this we get the answer to be 74. So the combined average here is 74, right? 80, 70 would be class A, class B, and the combined average is 74. Now what the GMAT explains in terms of weighted average is this. This value of 74 is weighted more towards 70 than towards 80. Since this overall average 74 is weighted towards 70, the weight of class B has to be much more. And it's very clear that looking at class B, that the number of students here is 30. So if the number of students is much more, it's going to give me a bigger sum, and a bigger sum contributes to a higher weight in terms of the average. So the overall average should be closer to 70 than towards 80. Now that's one way to look at weighted averages, right? But another way to look at weighted averages is in terms of what we call the alligation or the mixture diagram. Now what the alligation and the mixture diagram does is it uses the same weighted average concept but brings in the concept of a comparison in terms of a ratio. For example, the alligation of the mixture diagram consists of 4 arms. The left arm holds what we call the higher value. The right arm holds what we call the lower value. And when we mix a higher value with a lower value, what we get is something in between. So we refer to that as the mean value. Now what we do with this alligation of the mixture diagram is we always subtract the quantities along the diagonals. So HV minus MV is what we get at this point, and MV minus LV is what we get at this point. What we end up getting once we subtract along the diagonals is a ratio in which the two quantities are mixed. So what we end up getting is the ratio in which the higher value is mixed to the lower value to get the mean value. Now there are a couple of things that you need to keep in mind when you're solving the mixture diagram. Okay, first, whatever quantities you use for the higher value, lower value, and mean value, they have to be associated with the word per. Right? They have to be quantities which are variable quantities. For example, $50 per kg, 50 kilometers per hour, 50%. You can also use averages, right? Because average, when I say the average marks of a student in a class is 80, then I'm ideally saying that every student's mark is 80. You can also use it for fractions because fractions also associate with the word per. So you can make use of this alligation, the mixture diagram, not only while mixing solutions, you can always use it when you're mixing quantities which are associated with the word per. All right. And the second is you always have to make sure that the higher value, lower value, and mean value have to be associated to the same thing. For example, if you're using the percentage of alcohol, then you need to use the percentage of alcohol everywhere for the higher value, lower value, and mean value. If you're using the percentage of water, you use water, water, water in all three cases. If you're using averages, you use average, average, average. If you're using prices per fruit or prices per piece of vegetable, you're going to use price, price, price. If you're going to use fractions of copper, you use fraction of copper for higher value, fraction of copper for lower value, and fraction of copper for mean value. So they have to be associated to the same thing. So this format of the alligation and the mixture diagram and these 2 points are very important for you to think about using this procedure to solve the weighted average concept. Okay. So just correlating the things here, I'm going to use the same example that I had previously. I said that you have a class and the average marks is 80. You have another class, the average marks are 70. Now what you're doing is you're combining the 2 classes. So you're mixing these 2 averages, right? And I know that the ratio of this entire class by the number of students, since I gave you the number of students as 20 and the number of students as 30, the ratio of this entire class is 20:30, or in other words, the ratio is 2:3. So if I need to find out the overall average of the entire class, I'm going to make use of the mixture diagram. I'm going to keep the overall mean value to be X, and I'm going to subtract along the diagonals like how we worked out in the general format of the mixture diagram. So this is going to be 80 minus X, and 80 minus X is going to represent 3 parts of your ratio, and X minus 70 is going to represent 2 parts of your ratio. So if I need to solve for X here, I'm going to cross multiply. So 160 minus 2X is equal to 3x minus 210. So 5x is equal to 370. X is going to be equal to 74. So we get the same 74 value by using the concept of the ratio of the class of the number of students to the class, which is 2 is to 3, right? Now the good thing about using the alligation of the mixture diagram is you do not only pertain yourself in using the alligation of the mixture diagram only while mixing solutions. You can use it when you mix averages in terms of the weighted average concept, when you're mixing fractions, when you're mixing percentages, and when you're also mixing any quantity which is associated with the word per. All right. Why do we cross multiply, Manisha? Because that's the procedure of working, right? I mean, if I give you a ratio, right? If 4x is to 5x is equal to say 4x plus 5 is to 5x plus 6 is equal to 7 is to 9. How will I solve for this? You're going to say 4x plus 5 divided by 5x plus 6 is equal to 7 by 9, right? And we cross multiply. So if I tell you 4x plus 5 is equal to 7, basically what you're doing here is 4x plus 5 is equal to 7 and 5x plus 6 is equal to 9, and you're cross multiplying here. It's the same procedure of how you solve for a ratio. Okay. So what we basically do is we utilize the mixture diagram for all concepts or all weighted average concepts, all quantities which are associated with the word per. Okay, so that is one thing. In case of different things mixed, how is this ratio changed? What do you mean by that, Moksha? I mean, what do you mean by different things mixed? Now, when you have different things mixed, so if you have alcohol and water, if you mix 3 quantities at a time, you always take 2 quantities at a time and you work with it, right? If you're going to mix 3 quantities, you take 2 quantities, you work with the first 2 quantities, you take the ratio and you then take the next 2 quantities, you take the ratio and then you combine the 2 ratios, isn't it? So you know how to combine ratios. Suppose I give you A is to B as 2 is to 3, and if I give you B is to C as 4 is to 5, you see I've taken two quantities at a time, right? Now I know how to combine this entire ratio to get the overall ratio of A is to B is to C, right? So you just take the quantities two at a time, find out the ratios individually and combine the ratios to get the overall ratio. All right. So it doesn't change. Nothing changes there. Perfect. Now, just to justify, just to make my point that this entire mixture diagram need not be only used for mixing solutions. I've picked up a couple of questions from the official guide. I've also picked up a couple of questions from the GMAT prep tests, and that's going to be the agenda of the session. Okay, I'm going to discuss only actual GMAT questions and show you how this concept of weighted average or mixtures can be used in that. Okay, so here's your first question, very, very simple one to start off with. It's a question that is present in the official guide. So quickly, you take a minute, give me an answer for it, please. Guys, please don't type the answer in the chat window, right? Once I say your time is up, that's when all of you all can type in the answer, all right? All right, you can type in your answers in the chat window, please. All right. Most of y'all are giving me the right answer. So some of y'all have given me echo, some of y'all have given me alpha. See, one thing you need to be a little careful about if you're going this process of working, right, is you need to understand the concept of ratios very, very clearly, right? You need to work with ratios. You need to know how to represent ratios as fractions. You need to know how to represent ratios in terms of percentages and so on. So here clearly this is an indicator of a question. Yeah, that's right. XT 1562 is 33.33. Now here, whenever you see questions, right, the first instinct is on what questions do I use this mixture diagram? It's simple. Whenever you see that you're mixing any quantity which is associated with the word per, whether it's a ratio, whether it's a fraction, whether it's an average, you can make use of this. So clearly here you're mixing quantities which are associated with percentages. So I have seed mixture X, which contains 40% rye and 60% blue. And I have seed mixture Y, which contains 25% rye and 75% fescue. And the mixture X plus Y is going to contain 30% rye. And the question asks me what weight of the mixture is X. So clearly, percentages here are being mixed, and the value which is associated to each other as the percentages of ryegrass in X, Y, and X plus Y. So I'm going to create the mixture diagram. I'm going to create the mixture diagram for the ryegrass. So we have 40% rye, and this would be for X. We have 60% rye, this would be for Y. If you want, you can switch it. If you want to maintain the mixture diagram to be as it is, you can keep the higher value on the left hand side and the lower value on the right hand side. So it's 40% X, then we have 25% in Y, and finally we have 30% in X plus Y. So 40 minus 30 gives you 10, 30 minus 25 gives you 5. So the ratio here is 1:2. So what have we got here? The ratio of X is to Y. For me to get a 30% solution, I need to mix X and Y in the ratio 1:2. Now the question asks me what percent of the weight of the mixture is X. Now if you have a ratio 1:2 and you need to convert this to a percentage, the first thing you do is you convert it to a fraction. So it's going to be 1/3 and 2/3. And then you convert the fraction into a percentage by multiplying by 100. So 1/3 into 100 would give you 33 1/3, and 2/3 into 100 would give you 33 1/3. Would give you 66 2/3 if you multiply by 2, right? So clearly here, if I need the ratio 1:2, and the question asks me what percent of the weight of the mixture is X, 1 out of 3 represents 33 1/3%. So the answer here clearly is B. Okay, guys. So just starting off with a very, very simple one, just for you to get a hang of how exactly we're going to use the mixture diagram. So I use the percentage concept where you're going to mix a quantity which is associated with the word per. We got to the ratio and then we use the ratio to solve the question, right? Most of you are giving me an answer, so I'm going to make this a little more challenging, a little more tougher. So here's your second question, please. All right, guys, you can start typing your answer in the chat window. Why is the question mark with 44? Yes, Ria, you can make use of the method of back solving if you want, right? There's alternate ways. There's a lot of alternate ways to solve this. You can create equations also if you want with this. You can also use a mixture concept because yes, it would definitely be tedious. That wouldn't be a feasible approach to work with, right? All right, guys. Yes, XT1562. You can approximately solve it. You don't need to, I'm assuming that you converted the 15 by 64 into a percentage, right? If you use the approximation, that's what I'm assuming you did, right? Perfect, perfect. So I see very few people have given me the answer for this, right? Maybe a handful, three or four. What happened? I mean, I would want all of you all to type in what exactly was the issue that you faced in this question. There are multiple approaches to solve this, right? You can create equations out of it. You can also work it using the answer choices. You can also use the concept of mixtures. So what problem did you face in this question? I just made the previous question slightly harder here. So if you can type in the chat window what exactly was the problem you faced, I can address that. Exactly. So exactly. So Arun has figured this out, right? So what we have here is we have two brands, brand P and brand Q, right? So brand P's mixed nuts are 20% almonds, and brand Q's deluxe mixed nuts are 25% almonds. So clearly, here I have 20% and 25%, two ratios given to me, isn't it? Two percentages, which I can obviously convert into a fraction or a ratio. Yes? So 20%, I'm going to convert it into a fraction, which is 1 by 5, right? And this is brand B. Brand Q, we have 25% of almonds, which would be 1 by 4. Now, if the bowl contains a total of 64 ounces of nuts, representing a mixture of both brands, and 15 ounces of the mixtures are almonds, so what they're giving me is they're giving me the fraction of P plus Q, which is 15 by 64. Now, there are two ways. One way is what Mr. XT1562 did, is he converted the 15 by 64 into a percentage, into an approximate percentage, and then he used all the percentages, the 20, 25, and the approximate 15 by 64 percentage, and worked with the ratio. But the problem with that XT is you need to understand that if you approximate things, right, in this question, the approximation would work fine because the answer choices given to you are nicely spread apart, right? If I give you answer choices which are very, very, very close to each other, right? For example, if I change answer choice D to 42, then you're going to be in very, very big trouble. So the safer approach, right? The safer approach, since I've been given percentages and here I've been given a definite value, would be to convert the percentages into a fraction and then use the fractions to figure out what values you're going to use in the mixture diagram. And another thing, right, is if I'm using the fractions also in the mixture diagram, basically I'm going to use 1 by 5, 1 by 4, and 15 by 64. It's not going to be very feasible for me to subtract the fractions because the denominators are different. So what I'm going to do is I'm going to find out the LCM of 5, 4, and 64, right? And you'll realize the LCM here is 64 into 5, which is 520, 320. And I'm going to change all these fractions 1 by 5 into something divided by 320 so that I can keep the denominators the same. So if I keep the denominators the same, I just need to work with the numerators of the entire fractions. So 1 by 5, if I need to convert it to a base of 320, 5 6 are 30, and 5 4s are 20. That's going to be 64 by 320. And 1 by 4, if I'm going to convert it into a base of 320, this is going to be 320. 4 8s are 32. That's going to be 80 by 320. And 15 by 64, I'm going to convert to a base of 320. 64 into 5 is 320. So 15 into 5 gives me 75. So this would be an easier approach to work, right? Because now when I've kept the base the same, all I have to do is use the mixture diagram for the numerators of the fractions. And what are the numerators of the fractions here? They are 80 for Q, 64 for P, and it's 75 for P plus Q. Yes, Fabik, you can multiply 15 by 64 by 100 to change it to a percentage, but I'm not changing things to a percentage here. What I'm doing is I'm changing the percentages to a fraction and I'm making use of the fraction. 15 by 64 to change it to a percentage is going to be very, very difficult because it doesn't give you a definite answer, right? It gives you a decimal value, right? And I'm not going to work with decimal values here to find the ratio because I'm going to get an approximate answer. So what I've done the next best thing. The next best thing is to convert the percentage into a fraction and use the fractions to work. Yes, so some of them did that. That's what XT did. They approximated to 16 by 64. But the problem is, if I give you answer choices which are very close, it's going to be a problem, right? Yeah, you can use it, Ria. You can use 1 by 5 and 1 by 4 and 15 by 64 in between. But it involves more calculations, right? You have to do 1 by 4 minus 15 by 64. You have to take the LCM, then subtract and so on. So what I did is instead of me subtracting all those values, taking LCM and so on, I kept the basis to be the same. So once I keep the basis to be the same, right, I just have to worry about the numerators of the fractions. Got it? So 80 minus 75 gives me 5 and 75 minus 64. So 75 minus 64 has to give me 11. So clearly here, the ratio of Q's to P. So clearly here, the ratio of Q's to P is 11 is to 5. Now think about this. If the ratio of Q's to P is 11 is to 5 and we have a total of 64 ounces of nuts, I know 11x plus 5x has to be equal to 64. Yes, using the rule of a ratio, 11x plus 5x has to be equal to 64. So clearly 16x is 64 and x is going to be equal to 4. And the question is asking me how many ounces of brand Q's deluxe mixed nuts are used. Brand Q is given by 11x parts of my ratio. So 11 into 4 gives me the answer delta 44. Got this, guys? So at some points, right, especially on the harder level questions, your manipulation skills in how you convert a fraction into a percentage and how you convert a percentage into fraction will make more sense, right? Never do extra working because you're not going to be given brownie points for those extra working, right? At the end of the day, you need to get an answer in under 2 minutes. Got this, guys? So what happened in this question is they didn't spoon feed you with all 3 percentages. They fed you with 2 percentages, but then they give you a mixture which is in terms of a fraction. So I converted everything to a fraction and then used the mixture diagram to find the ratio. Okay with this? Okay, this guys, can we move on to the next question? Perfect. So here's the next question. This is question 3, again, classified as a 700 level question in the official guide. So I again want you to take 2 minutes. Give me an answer at the end of 2. Please don't type the answer in the chat window until I say so. I've done that, Vimal. All right, guys, you can start typing the answer in the chat window. All right. So let's have a discussion on this. Are all of you all able to see the screen? I've just zoomed in. So just confirm if you can see the screen, please. I can continue with the explanation of the question. Perfect. Now, at a certain food stand, the price of each apple is 40 cents and the price of each orange is 60 cents. Mary selects a total of 10 apples and oranges from the food stand, and the average price of the 10 pieces of fruit is 56 cents. So clearly here, I have prices which are associated with the word per being mixed. So each orange costs 60 cents. Remember, it's 60 cents per orange, right? So this is the orange. These are the apples, which cost 40 cents. And you know the average price of the 10 pieces of fruit is 56 cents. So 60 minus 56 gives us 4. 56 minus 40 gives us 16. Simplifying this, we get that the ratio of the oranges to apples is 4:1. Now, clearly, if the ratio of oranges to apples is 4:1 and Mary buys 10 pieces of fruit, if I need to have 10 pieces of fruit and the ratio is 4:1, we have to have 8 oranges and 2 apples. Right? So clearly, in the first pick, she's picked up 8 oranges and 2 apples, and the average price turns out to be 56 cents. But what happens now is the question asks me, how many oranges must Mary put back so that the average price of the pieces of fruit that she keeps is 52 cents? So what's happening now is I want the average price to reduce to 52 cents. But the price per orange and the price per apple is not going to change. So the price per orange is 60 cents. The price per apple is 40 cents. But I want the average to reduce to 52 cents. So if I need the average to reduce to 52 cents, then the new ratio of apples to oranges is 60 minus 52, which is 8, and 52 minus 12, 52 minus 40, which is 12. So the ratio here is 3 4s are 12, or simply 4 2s are 8, 4 3s are 12. So the ratio of apples to oranges clearly here is 3:2. Now think about this. Think about this. The trap answer here would be to select B, 2 oranges. Because what you'll have done is if you found the ratio 3:2 and you've still assumed that there are 10 pieces of fruit, then clearly you're going to get 6 oranges and 4 apples. And if you have 6 oranges from 8 oranges, obviously you're going to keep back 2. But remember, guys, just bring in logic here. If Mary keeps back certain oranges, the total fruit is not going to remain 10. It's going to reduce to less than 10. So the better way to solve this out would be to keep the apples as your reference. Now we know that she's always picked up 2 apples and she's only going to keep back some oranges. So the number of apples is still going to remain constant. So clearly she still always has 2 apples. And if I need to satisfy this ratio 3:2 and I have 2 apples, then the only way I can have this 2 apples is 3 oranges. Right? So the ratio here is 3 oranges to 2 apples. So there are 3 oranges and 2 apples, and first time she picked up the 8 oranges, and the second time she has only 3 oranges left, the number of oranges she keeps back is going to be 5. So the answer here is echo, 5. All right? So you have to be a little careful here. Now what normally people would do on this question is they would create equations. Let me keep the number of oranges as O, the cost of oranges is given as 60 cents. Let me keep the number of oranges as O. The cost per apple is 40 cents. Go and see the last part is very simple, right? The ratio of oranges to apples in the second case is 3:2. Now you can't assume that there are still 10 pieces of fruit because she's going to keep back some oranges. So the number of fruit has to reduce. So the better way to solve it, right, is to keep the apples to be constant. She's picked up 2 apples in the first case. She has the 2 apples with her. She's not going to keep back any oranges. So I need to have 2 apples for sure. And this 2 apples represents 2 parts of my ratio. So if 2 apples represents 2 parts of my ratio, to have the ratio 3:2, there has to be 3 oranges. So in the second case, she has 3 oranges for every 2 apples. So from 8 oranges, if the number of oranges reduces to 3, the difference is going to be 5. So she keeps back 5 of the oranges. All right. Perfect. So again, here what happened is we used the weighted average concept in 2 stages, right? Because they gave me 2 different averages, one with 56 and one with 52. But you realize that the ratio that you found out, was very, very simple to calculate, right? And from the ratio, we could analyze a lot of things and get to an answer. The only thing you have to be a little careful about is the trap answers that, the GMAT would lay, and beta 2 would be the ideal trap answer because people would assume that the total number of fruit would remain to be 10. Okay with this, guys? Can we move on to the next question? Perfect. So this next question, right, deals with the concept of standard deviation, all right? I want all of you all to take a stab at this question. I want to see the answers that you give me for this question. Again, this is an official GMAT question. And I would give you like a good brief explanation of what standard deviation is, and then we'll come back to solving of this question. Okay, so take 2 minutes, solve this question, give me an answer, and then we'll come back and we'll discuss this question after I deal with the concept of standard deviation. All right, guys, you can key in your answers here. All right, I see a lot of contradictory answers in this. All right, I still want answers from the others. I've only got around a handful of them. All right, perfect. So I'm first going to explain the concept here associated with this. Okay, so I'm just moving on to a Word file. Now, what standard deviation basically is, is it measures the dispersion from the mean. If I give you a set x1, x2 till xn, and I define x bar to be the mean of that set, then the standard deviation, represented by sigma, but I'm just using SD here, is given by root of x bar minus x1 whole square plus x bar minus x2 whole square plus x bar minus xn whole square, whole divided by n, right? Basically what we're doing with this formula is we are finding the dispersion from the mean, okay, of all the other elements. See, I don't want you to worry about the formula. The formula looks very, very fancy, but you need to understand standard deviation just in this simple way. Standard deviation is defined as a fraction, where the numerator of the fraction is always a deviation from the mean, and the denominator of the fraction always represents the number of elements. So if you understand standard deviation as a fraction, things become very, very, very easy for you to solve. Standard deviation basically depends on two things. The standard deviation depends upon the deviations from the mean on the numerator, and it also depends upon the number of elements on the denominator. The standard deviation does not directly depend upon the mean. Keep that in mind. It depends upon the deviations from the mean. Just if I have just the information of the mean of a set, I will not be able to find out the standard deviation because I don't know the other elements of the set. Because the numerator always depends upon the deviations from the mean. And to find the deviations, I need all the other elements of that set. And also keep in mind that the standard deviation would also depend upon the number of elements. Why did I pick this topic of standard deviation to discuss during this session? Because I've seen a lot of people, not understanding standard deviation in a proper way. For example, on one of the forum posts, I've seen somebody posting something of this sort: 1, 2, 4, 5, and somebody posting another set 1, 2, 3, 4, 5. And the question that the person asked was, are the standard deviation of these two sets exactly the same? And the answer given was definitely yes. Now, the justification for that was the mean of this set is 3. The mean of this set is also 3. So the deviations of all the elements are -1, -2, +1, +2. And the deviations of all the elements in the second set are -1, -2, +1, +2. So the deviations from the mean are the same. So the standard deviations are exactly the same. Now, this is a big, misunderstanding of the concept. You need to understand the standard deviation does not only depend upon the deviation from the mean. It also depends upon the number of elements of that set, right? The number of elements here is 4 and the number of elements here is 5. So clearly the numerator is the deviations from the mean. So the deviations from the mean are constant and the denominator of the elements here is 4 and here it's 5. Clearly the first set is going to have greater standard deviation over the second, because the numerators are the same. The one with the smaller denominator is going to be the greater fraction. So you need to keep in mind standard deviation depends on two things. It depends upon the deviations from the mean and also depends upon the number of elements of that set. Now, like I said, right, if you understand standard deviation in terms of a fraction, then things become very, very simple. Say I give you an example: 1, 2, 3, 4, 5. I take a set 1, 2, 3, 4, 5 and I add a constant 7. I add a constant 7 to every element of that set. So 8, 9, 10, 11, 12. So if I ask you to compare the standard deviations of both these sets, would the standard deviation be the same, or would one set have a greater standard deviation over the other? Perfect. It's definitely going to be the same. The reason the standard deviations are going to be the same, think about it as a fraction. Don't worry about the formula. Standard deviation is a fraction where the numerator is the deviations from the mean and the denominator is the number of elements. Clearly here in both cases, the number of elements are 5. In the first set, the mean is 3. The deviations from the mean are -1, -2, +1, and +2. In the second set, the mean is 10. And the deviations are -1, -2, +1, and +2. Just to make a note, right? Just to make a note, guys, based on the formula, don't just cancel out these -2, -1, +1, and +2, okay? Just because you're adding all the deviations. Remember, you're squaring the deviations and adding them. So ideally, the -2 becomes 2 square. That's 4. And the -1 becomes 1 square. 1 square and 2 square. And in the second case also, -2 becomes 2 square, 1 square, 1 square, and 2 square, right? So if the first set has the same deviations from the mean, the second set also has the same deviations from the mean, I'm going to have two fractions where the numerators are the same and the denominators are the same. So the standard deviation is going to exactly remain the same, despite the fact that the mean changed. So the first property of standard deviation states, you can always add or subtract any quantity. You can always add or subtract any constant or any quantity to every element of a set, and the standard deviation remains the same. If you add or subtract any quantity to every element of a set, then the standard deviation also remains the same. Logically, the numerator remains the same and the denominator remains the same. Okay with this, guys? The first property of standard deviation. You can add anything you want, you can subtract anything you want. The standard deviation is going to remain the same, but you have to do it to every element of that set. Okay with this, guys? Perfect. Second, this time I give it the same set 1, 2, 3, 4, 5, but I multiply every element of the set with a constant. So 7, I'm going to multiply with the 7, okay? 14, 21, 28, and 35. So I've multiplied every element here by 7. Now, if I ask you to compare the standard deviations of the two, would the standard deviations remain the same, or would one set have greater standard deviation over the other? Exactly. Yes. So the reason we get this here, again, the denominators are going to be exactly the same. There are 5 elements in the first set. There are 5 elements in the second set. The numerator of both these sets, the numerator of the fraction basically depends upon the deviations from the mean. Here the mean is 3. So this is -1, -2, +1, +2. Here the mean is 21. So it's -1, -2, +1, +2. Guys, for those who don't know how I'm getting the mean as 3 and 21, it's just a property of arithmetic progression. It's first plus last by 2, right? I'm assuming that you guys know that you can find out the arithmetic mean by taking the first element and adding the last element and divide by 2, or taking the median of that set, right? Because for an AP, the mean will always be equal to the median, right? I'm not doing the working because that's a prerequisite for you to know before coming into the session. So clearly what has happened here, by keeping this as -7 minus, I'm just going to find the deviations here. This is 21, so this will be -7, this would be -14, this would be +7, and this would be +14. So what happens here is the deviations are increased. So when I remember, guys, you're always squaring the deviations and you're adding them up, right? So what you're doing here is this fraction has a very small numerator, but the second fraction, because the deviations are large, is going to have a greater numerator. So if I have two fractions where the denominators are the same and one fraction has a greater numerator over the other fraction, then clearly the second fraction is going to be greater than the first. So the standard deviation of the second set is definitely going to be greater than the standard deviation of the first set. So the second property of standard deviation states you can always multiply or divide every element with a constant, right? But what happens when you multiply or divide? If you multiply every element of the set with a constant, the standard deviation increases. If you divide every element of the set with a constant, the standard deviation decreases. And how much would they increase and decrease by? The same factor that you multiplied every element of the set. Here you have -14, -7, +7, and +14, right? If we take -7 common, we're going to get back -2, -1, +1, and +2. So the second set is going to have 7 times more standard deviation over the first, right? So if you multiply every element of the set with a constant, the standard deviation increases. If you divide every element of the set with a constant, the standard deviation is going to decrease. How much they're going to increase and decrease by? The same constant that you multiplied and divided every element of that set. Okay with this? All right. What if I give you this? Again, think about things in terms of fractions, right? I give you a set 1, 2, 3, 4, 5. This time, I give you an opportunity to add 2 quantities to the set such that it gives me the greatest reduction in standard deviation. I want you to add 2 elements to the set which gives me the greatest reduction in standard deviation. So what 2 elements will you add to a set which gives you the greatest reduction in standard deviation? Exactly. I'm going to add 2 values which are equal to the mean. So if I take 1, 2, 3, 4, and 5, here clearly the mean is 3, the deviations are -1, -2, +1, +2, and we have a total of 5 terms. If we add 2 values which are exactly equal to the mean, we are increasing the denominator from 5 to 7. But ideally what we are doing is we are not changing the mean of the set. And we've added two elements since they are equal to the mean. We have not added any deviation to the original set that is given to us. The original set is -2. The deviations are -2, -1, +1, and +2. The new set also has the same deviations of -2, -1, +1, and +2. Right? So what we've done, we've just increased this denominator from 5 to 7, but we've kept the numerator constant. And if we keep the numerator constant and increase the denominator, the entire standard deviation reduces. And the best values that you can add to a set, which greatly decreases the standard deviation, are values which are equal to the mean. So whenever you need to choose values to decrease the standard deviation of the set, it's always better, if you want the greatest possible reduction, to add values which are equal to the mean, because you just increase the denominator, you don't increase anything in the numerator, right? So these are the three things that you need to keep in mind while you're working for standard deviation, right? So coming to this question, what did the question tell you here? The question said, during an experiment, some water was removed from each of the 6 tanks. If the standard deviation of the volumes of water in the tanks at the beginning of the experiment was 10 gallons, what was the standard deviation of the volumes of the water in the tanks at the end of the experiment? So I need to find out, if I have an initial standard deviation, I know that the standard deviation is 10 gallons at the beginning. What is the standard deviation at the end of the experiment, right? So for each tank, 30% of the volume of water that was in the tank at the beginning of the experiment was removed during the experiment. So think about this, guys. I have 6 water tanks, right? Or I have 6 elements in a set. Now what is happening? During the experiment, I'm decreasing every element by 30%. So what happens? If this original set is going to have some amount of standard deviation, and I reduce the same quantity from every element of a set, the standard deviation is exactly going to remain the same. So think about this, guys. The rule is, whenever we remove any quantity from each element of the set, if I remove the same quantity from every element of the set, the standard deviation is going to remain the same. But here we do not know what are the individual volumes in each of the water tanks. But I know that if I remove 30% from each, then the standard deviation for sure is going to reduce by the same value of 30%. So if we have the standard deviation as 10 gallons in the first case, then if I remove 30% of volume from each of the tank, the standard deviation in the second case is going to be 70% of 10, which is 7 gallons. All right. So the first statement is clearly sufficient, and the two possible answer choices are AD. The second statement tells me the average volume of water in the tanks at the end of the experiment was 63 gallons. Now think about this. What does standard deviation depend upon? Standard deviation depends upon two things. It depends upon the deviations from the mean, and it also depends upon the number of elements. Now clearly we have the number of elements here. It's 6. But here I have only the mean. In the second statement, I just have the mean given to me. I don't have the individual values of all the other elements in that set. So I can't find out the deviations in that set. So clearly the second statement is insufficient. The answer here is alpha. Okay with this, guys? So most of you all gave me alpha. Some of you all gave me different answers, Charlie, Delta, Echo. So clearly the first was sufficient, because when I reduce everything by 30%, the entire standard deviation also reduces by 30%. Okay with this, guys? Perfect. So I'm moving on to the next question. Again, based on standard deviation. Very, very simple. If you understood what I discussed in terms of the properties, this should be a very quick kill. So take 2 minutes. Give me an answer for this, please. No, Dora, it's not going to remain 10. It's not going to remain 10 because uh, see, you're not removing a constant from every element, right? Because it depends upon each values of the volume of all the water in the tanks that are there in the set, right? The volumes are all different. So, for example, if you have 1 liter, 2 liters, 3 liters, 4 liters, 5 liters, right? If I remove 30% from everything, it's different values that I am reducing, right? So in the first case, if I reduce 1 liter by 30%, it becomes zero point 0.7, correct? Two, if I reduce by 30%, it becomes 1.4, right? So the values that I reduce from each of the terms is different. That's why I said the standard deviation has to be, 70% of the original. Okay, guys, most of y'all here who gave me an answer, falling for a trap, right? It's very, very clear, right? This question is like a 20-second question. You should give me the answer. It's clear that answer choice three is a very illogical pick, right? Answer choice three is a very illogical pick because you know for a fact that here, if I subtract, add, and subtract random values, the standard deviation is definitely going to change, right? But if I look at R, S, and T, what is happening in the first case is I'm subtracting a constant to every element of the set. So if I subtract a constant to every element of the set, the standard deviation is definitely going to remain the same. So one is definitely a pick, right? So out goes B, out goes, I can't have three, so out goes D and out goes E, right? Now, even the second one would hold good, right? Because what is happening in the second one is you're just subtracting S from every element of the set. R minus S minus S, and T minus S. You're again subtracting a constant, right, from every element of the set. So you're going to get R minus S, 0, and T minus S. So if you subtract a constant from every element of the set, again the standard deviation is going to remain the same. So the second also would hold good. So the answer here has to be C, 1 and 2 only. Yes, Fabik. The SD reduced by a factor of 30%, right? If it was 10 gallons, the SD reduced to 7 gallons because I'm reducing every term by 30%, right? It's not going to remain the same. When is the standard deviation going to remain the same? When I remove a constant from every element of the set. The deviation is not zero. How is the deviation zero, Santosh? How is the deviation zero? If I have three elements R, S, and T, if I have three elements 1, 2, and 3, and if I subtract 4 from one element, I make it minus 3. I add 5 to another, which is 7, and I subtract 1, I make it 4. Now here the deviations would exactly be different, right? Compared to the first, the mean is 2 here, so this would be minus 1 and plus 1. The mean here is going to change, the deviations are going to change, right? How are the deviations minus 4, minus 1, and 5? I don't understand that. How are the deviations minus 4, minus 1, and 5? It's always a deviation from the mean, right? How do you know what is the mean of that set? R minus 4, S plus 5, D minus 1. I give you an example here with numbers, right? If I take 1, 2, and 3 as R, S, and T, and I subtract 4 minus 3, 7, and 4, 7 plus 4 is 11. 11 minus 3, 7 plus 4 is 11. 11 minus 3 is 8, right? So if I divide 8 by 3, the mean here is going to be 8 divided by 3, which is 2.66. The deviations are way different from what the first set is, right? All right. So can you move on to the next question? Okay. So here's the next question. Another type of question that you're going to find, another type of question you're going to find on the GMAT is are questions based on must be trues and could be trues. Okay. These are slightly tricky. So here's a question for you. Again, take 2 minutes, give me an answer, and then we'll look at how to approach questions on must be and could be. All right, guys, can key in the answers. All right. So before we go into this question, right? Before we go into this question, or let me do this. Let me explain the concept of must be's and could be's with this question itself, right? Uh, Keep in mind that whenever you deal with a must be type of question, or to be more specific, a must be true type of question, you never try to prove the answer choice to be true. You always try to disprove. That is, you try to find one case which is false. Because what happens, right? If I try to find one case which is false, I know that that statement is definitely not going to be true. I'm saying that if you have a must be true question, you never try to prove the statements to be true. You always try to disprove. You always try to find one case to prove the statement to be false. Because what happens when you prove it to be false, you know the statement will not hold to be true always. So whenever you approach any must be type of question, your approach should be always to disprove the statements rather than to prove. I'm going to work with this one by one by one. So we have 15 homes, right? So I'm going to keep 15 dashes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, just to explain things better. The average price of the houses was 150. So average sale price, I know the mean here is going to be $150. I'm just cutting out all the zeros. So I'm just taking the mean to be $15. And the mean is $15. The total of all the houses is going to be $15 into 15, which is $225. Guys, I'm just not using the zeros. I'm just working without the zeros. So assume that the zeros are there beyond those numbers, right? So the mean is 15. So the total of all these houses has to be 225. It can't cross 225. It can't be less than 225. It has to be equal to 225. And they told me that the median price is 130,000. So the median clearly here is the eighth element. So 1, 2, 3, 4, 5, 6, 7, 8. So the eighth element here is $13. Right? Now, as soon as you put the $13 as the median price of the houses, you need to understand that all the elements in the set are going to be arranged either in ascending order or descending order. So I'm going to consider the ascending order representation. So all the elements to the left of the median have to be less than or equal to 13, and all the elements to the right of the median have to be greater than or equal to 13. Right? Now, this is the information that I've processed from the question given to me. Now, if I scan my way through the answer choices, if I look at the third answer choice, at least one home sold for less than $130,000. So looking at it clearly, if the median is $13, I know I'm going to have the 7 houses to the left of the median to be less than $13. But whenever you look at a statement, you never try to prove it. You always try to disprove it. And the way I can disprove the third statement is to keep the prices of all the first 7 houses to be equal to $13. And this is a very legitimate scenario which disproves the third statement. So I know the third statement, since it's disproved, can never be true, always true. It can be true if I have one of the values to be less than $13, that's absolutely fine. But I am trying to disprove the statement rather than to prove it. Got it? Okay with this, guys? So the third statement for sure is not going to be a pick. Out goes Echo, out goes Charlie. Okay with this? All right. So remember, guys, whenever you have a must be type of question, never try to prove, always try to disprove. Now, I scan the second answer choice. The second answer choice tells me at least one home or at least one house sold for $130 greater than $130,000 but less than $150,000. I'm not going to try to prove the statement. I'm going to try to disprove the statement. I'm going to run with the same example here, because here, by taking all the prices of the first 8 houses to be $13, I've already disproved the first half of the second statement. Now I can keep all the houses to be equal to $13. So 13, 13, 13, 13, 13, 13. So that's 13 into 14, 13 into 14, 14 threes are 42, 14 ones are 14 plus 4 is 182. So the cost of the last house should be 225 minus 182, which is 43. So the cost of the last house would be 43. So clearly, even this is a legitimate scenario, having all the houses, all the first 14 houses to each cost $13 and the last house to be $43. This entire scenario is going to disprove the second statement, which says at least one house sold for greater than $130,000 but less than $150,000. Out goes 2. So if out goes 2, out goes answer choice is B, out goes answer choice is D. You're left with only one possible pick, and that is alpha. Okay with this, guys? So remember, whenever you have a must be type of question, always try to disprove. Never try to go ahead and prove. Yes, when we use 13 for the first 7 values, I'm not going to have at least one home to cost less than 130,000, right? So the third statement is definitely disproved. So let's try to do that. So what I do with the second statement, Sham, is I kept all the first 14 houses to all be $13. So if the first 14 houses are all $13, the sum of the first 14 houses would be 182. The last house has to be $43. So I can have the scenario where all the first 14 houses are $13, the last house is $43. That is enough for me to disprove the second statement, right? Because the second statement tells me at least one house costs greater than $130,000 but lesser than $150,000. I don't have any house in this scenario which is greater than $130,000 but less than $150,000. Vimal, it's never a good sign to always try to prove in a must be true. Okay, never try to prove. But what I'll try to do, right? What I'll try to do in that first statement, right, Vimal, is I'll try to disprove it. Okay, I'll try to disprove. If I'm not able to disprove, right, it's going to be true for sure, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So I took the 8th house as $13. So 1, 2, 3, 4, 5, 6, 7, 8. This is 13. Now let's use the first scenario, Vimal, okay? Let's use the first scenario where I took all the first 8 houses to be 13. I'll keep all the remaining houses also to be 13 and the last house to be $43, okay? Think logically now. Now, if I want to prove the first statement tells me at least one house sold for greater than 165,000. So this 43 is the one which definitely gives me that truth case for the first statement, right? Because it's greater than 165,000. So let me try to drop this value to lesser than 165. Let me try to make it 16. Now think about this, Vimal. If I drop 43 to 16, think about it. If I drop 43 to 16, what happens? I'm actually reducing the price by 27, right? Now, if the total has to be a constant 225, that reduction of 27 that I make by reducing 40 to 16 has to be compensated by increasing the prices of the houses by 16, right? Either I increase one price by 16 or I distribute the 16 as 1, 1, 1, 1, 1, 1, 1, 1 and so on with the other houses, because I always have to keep a constant of 225 as the total price of all the houses. So clearly, even this scenario that I've taken will not be able to disprove the first statement. I can take another scenario here, okay? I can keep all the first 8 houses to be 13, 13, 13, 13, 13, 13. So 1, 2, 3, 4, 5, 6, 7, 8. And all the houses beyond that, so 9, 10, 11, 12, 13, 14, 15. See, 13 into 8, right, is going to give me 104. So since I need to have the total as 225, 225 minus 104 is 121. So all these last 7 houses have to take 121. You can't take the 14 houses as 15, Vimal, because the median is given to you as 13, right? So the median is the middle element, right? And it has to be of an arranged set. You can't have the values to the left of the median to be 15. It's not possible, right? So the other scenario would be to distribute this 121 equally. So 121 divided by 7 would be 7 ones are 7, 7 sevens are 49, would be dollar 17 point something, 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 17 point something. Now think logically again. If I try reducing the prices of one of these houses to less than 16.5, I have to compensate for this reduction by increasing the price of one of the houses on this right hand side, right? I can't increase the price of the houses on the left hand side because I can't cross 13, because the median is defined to be 13, right? Remember, the median is always the middlemost value of an arranged set. So the set has to be arranged either in ascending or descending order. So if I try to reduce the 17 to less than 16.5, I have to compensate for this reduction by increasing the prices of the houses to be greater than 17.5, because I need to maintain the sum to be equal to 225. So I will never be able to disprove the first statement. So if I'm not able to disprove the first statement, I'm going to definitely pick that as the answer choice. I'm not going to try to prove. I'm going to try to disprove. If I'm not able to disprove, I know that's going to be true always. Okay with this, guys? You can't take values greater than 13 on the left hand side of the median unless you're going in a descending order approach. If you're going in the ascending order approach, the values to the left of the median have to be less than or equal to the median. Okay with this? Can you move on to the next question? I have a couple of challenger questions here. So it's going to be a take back of what we did. Could be true. All you have to do, Manisha, is just to prove it to be true. The meaning of could be true is I just need to find one case which is true, right? So find out one case which is true and get done with your answer. The must be's are the trickier ones because you need to try to disprove. Could be true, sometimes false. So just prove one case to be true. That's sufficient. All right, guys. So here's a couple of challenger questions. Here's your first challenger question. I want to take 2 minutes. Try solving it. It's a good hard level question. I would rate this definitely at a good 740 or 750. I wanted to take 2 minutes and give me an answer, please. Excuse me. guys, you can start typing in your answer. Great, I've got only one answer yet. I'm waiting for the others. All right, so a couple of them have given me D as the answer, Arun and Moksha. So guys, can you just quickly type in what logic you used to solve this question? What is the logic behind solving this question? Keep the minimum at L, okay. Can you elaborate on that, Arun? Okay, fine, got it. Okay, so what, perfect. So what Arun is saying is this, okay? So he's keeping the lowest at L, right? He's keeping the lowest salary to be L. Now I know the highest salary is going to be L plus 10,000, right? I'm again forgetting the zero here, guys. So just bear with me on that, okay? L, the highest salary has to be L plus 10 because clearly the range here is given to me as 10,000. Range is always max minus min. So the average monthly salary, the average, that is the mean, is 7,000 above the lowest salary. So that's L plus 7,000. And the median salary is given to me as L plus 5,000. Right? So this is what Arun has done in the beginning. How did he proceed from here, Arun? How did you proceed from here? Perfect. You started off absolutely fine. How did you proceed from here? How would you figure out the total number of minimum value of n? Okay. Perfect. All right. That's one way to look at it. Perfect. Perfect. All right. Then you took the values as 10 and then you work with your answer choices and try to figure it out from that, right? Perfect. 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 So what Arun did is this, okay? I think he used the best possible approach to solve this question. It's a good hard one. So what Arun did is he first kept, like he said, he first kept everything to be L and L plus 10. He got the average to be L plus 7,000 and the median to be L plus 5,000. Now the problem here that I'm going to face is I know the median is L plus 5,000, but I have absolutely no clue. I have absolutely no clue of how many elements are there in this set, right? So the best thing to do is to always make use of the answer choices. If you're not able to proceed further, the best thing to do is to make use of the answer choices. So let me keep on, I'm going to start with the middle answer choice of 14. So if I have 14 elements in that set, If I have 14 elements in the set, then think about this. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have the first to be L, we have the second to be, last to be L plus 10. And if I have 14 elements, the middle two elements are going to be 1, 2, 3, 4, 5, 6 are going to be the seventh and the eighth element, right? If you have 14 elements, I'm going to have the seventh and the eighth element to be my middle two, because we have 1, 2, 3, 4, 5, 6 elements to the right and 1, 2, 3, 4, 5, 6 elements to the left. And the median has to be L plus 5000. This is going to be L plus 5 and this is going to be L plus 5. Right? In that case, the average of L plus 5 and L plus 5 is going to remain exactly the same. Now, what you can do, right? What you can do beyond this point, is you can use the concept of maximization and minimization, right? You can think about what can be the maximum possible values that the values to the right of the median can take, and what can be the minimum possible values that the values to the left of the median can take, right? So what can be the maximum possible values that the values to the right of the median can take? Think about it. What will be the maximum possible values the values to the right of the median can take? To the right of the median, to the right of L plus 10, perfect. So L plus 10, 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 right? And what are the maximum possible values the values to the left of the median is going to take? L plus 5, L plus 5, L plus 5, L plus 5, and L plus 5. These are the maximum possible values that I can put to the left of the median and to the right of the median. Now think about this. For this to be my answer, this maximum possible value has to add up to the sum of all these values, right? If I take the answer choice 14, n as 14, and I have the average, to be L plus 7000 or L plus 7, then the sum of all the values is going to be 14 into L plus 7. That's going to be 14L plus 98. So for this to be an answer, all of these values should add up to 14L plus 98. So let me check if it does. We have L plus 5, 1, 2, 3, 4, 5, 6, 7 times. So that's L plus 7 times L plus 5. And we have L plus 10, 1, 2, 3, 4, 5, 6 times. Plus 6 into L plus 10. So L plus 7L plus 35 plus 6L plus 60. 7 plus 6 is 13. 13 plus 1 is 14. So 14L plus 95 is what I get the sum to be when I keep all the values to be maximum. But the value that I should get is 14L plus 98. So clearly 14 is not a possible pick. And you'll realize that if 14 is not a possible pick, if I reduce the number of elements to 10 and 12, then the sum is never going to be equal to the sum of all the elements that is given. So I can eliminate 10, I can also eliminate 12. Here I need to increase the number of elements of the set for me to have an equality between the sum and number of elements. So if we keep 15 elements, now, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The eighth element, first 2, 3, 4, 5, 6, 7, 8. The eighth element here is going to be L plus 5. That's the median. This is L plus 10. And we have the first element to be L. So the maximum possibilities would be L plus 5 for all the elements to the left of the median and L plus 10 for all the elements to the right of the median. And here, since the average is L plus 7000 or L plus 7, since the average here is L plus 7, and we're going to have 15 elements, the sum is going to be 15 into L plus 7, which is 15L plus 105. So let's check if this gives us 15L plus 105. So that's L plus 1, 2, 3, 4, 5, 6, 7, 8. 8 times L plus 5. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's L plus 5, 1, 2, 3, 4, 5, 6, 7. That's 7 times L plus 5. Plus L plus 10 is 1, 2, 3, 4, 5, 6, 7. 7 times L plus 10, which is going to be L plus 7L plus 35 plus 7L plus 70, which gives me the total to be 15L plus 105, which exactly matches with what the average is going to be. So the possible pick here is 15. Okay with this, guys? The only difference that you did and I did, Arun, is you basically took the deficit from the mean, right? I just worked with the sum of the numbers, right? Perfect. Yes, perfect. All right, guys. So here's your last challenger question, and then we're going to stop this webinar in 5 minutes. Why didn't I want to minimize the values from the left, Manisha? Is because if I maximize the values, right, that gives me the maximum possible sum that I can have. If I minimize the values, right, it's not going to give me the maximum possible sum. The maximum possible sum I could have was 15L plus 105, right? So I wanted to see how can I get the 15L plus 105 by maximizing all the elements. Minimizing the elements wouldn't serve its purpose here. All right, guys. So couple of minutes shouldn't take you too much of time for this question. Give me an answer in 2, please. guys, so very simple question, right? If you start creating equations, this is going to be a big task to solve. So clearly when you look at this question, right, it's it's a clear indicator that you can make use of the mixture diagram. The question says each employee of a certain task force is either a manager or a director. What percent of the employees in the task force are directors? So I have managers, I have directors, and I need to find a percentage of employees of the task force which are directors. Remember, I don't need a definite value, I just need the percentage. So the first statement says the average arithmetic mean salary of the managers of the task force is 5,000 less than the average salary of all the employees on the task force. So let me keep the average salary of all the employees to be X. So the average salary of all the managers is going to be 5,000 less. Now what we're doing here is we are mixing the average salary of all the managers, that's X minus 5,000, with the average salary of the directors, which I have absolutely no information about, to get the overall average salary to be X. But here, since I have no information about the average salary of the directors, I cannot solve for the percentage of employees on the task force. So the first statement is clearly insufficient, BCE. Similarly, the second statement also is insufficient because it doesn't give me any information about the average salary of the managers. It gives me the average salary of the directors. It says that the average salary of the directors is 15,000 greater than the average salary of all the employees in the task force. I have absolutely no clue about the average salary of the managers. Out goes B. Now, when I combine the two statements, now this is where things become very interesting, right? You have the average salary of the managers as X plus 15,000. You have the average salary of the directors as X minus 5,000, and you have the overall average salary to be X. So clearly solving using the mixture diagram, we get 15,000 and we get 5,000. And clearly the ratio here is 1:3. So we have the directors here, we have the managers here, and the ratio of the directors to managers is 1:3. The percentages are going to be 25% and 75%. So clearly the combined statements are sufficient to solve the question. All right, guys. So these are a couple of things which are going to be tested on a slightly advanced level on the concept of stats, right? The concept of maximization, minimization, the concept of weighted averages, and also the concept of standard deviation and normal distribution. All right. Yes, Vimal, you can always get the recording of this webinar. All you have to do is send in a response to marketing at Crackverbal and they will provide you that, okay? All right, guys. So any last doubts? Any last doubts? Before I wrap up the session, we've already, exceeded it by 15 minutes. So perfect. Great. All right. Okay, guys. So then I'm logging off. Thank you. Have a great weekend, what is remaining of it. And also happy Diwali in advance. Good night.